Wow, let me tell you, that was a great trip visiting Hoot Gibson at the Dare County Airport in North Carolina. But you know, the variables of being outside in the wind and the rain can really get to you, and I'm glad to be back here in the Connect studio. Well, as Mike has said, it is today's students that will become NASA's future researchers. So let's go visit Jones Magnet Middle School in Hampton, Virginia, where students are investigating an aeronautical challenge involving surface area and glide ratio. Follow along. And when we come back, we'll look at the data collected by these students, and then you, my friends, will be challenged to make your own analysis and predictions based upon their results.
Hi, we're students from Jones Magnet Middle School in
Hampton, Virginia.
We were asked to investigate the glide ratio for different model airplane designs to determine which design provides the best glide ratio. The glide ratio of a plane describes the forward distance flown per drop in altitude in the absence of power and wind. For example, a 3-to-1 ratio means that if you are 1 mile up, you better be within 3 miles of the airport. Ms. Tomanak and Ms. Barnwell, our science and math teachers, divided our class into 4 teams. The blue team, the red team, the yellow team, and the white team. Each team will fly a different design.
To do our experiment, we used the following materials: copier paper. We used different colors to identify each team. We also used glue, a meter stick, and a tape measure. Each team was asked to select one design from the 4 patterns provided to us by NASA Langley. The shapes included the egret, the flex, the basic square, and the condor. Each team constructs a different model and calculates the total area of the paper used in creating the model. Next, we figure how much of the total area is actually devoted to the airplane's wing. Now we're ready to run our flight test.
For our baseline test, we decided to launch the airplanes at 2 2/10 meters from the ground. This becomes the plane's flight altitude. Our 4 groups conduct 10 test flights from this flight altitude. We're careful to launch each flight test from the same altitude and to be as consistent as possible in the force used to launch the airplane. We then measure the distance the plane goes from launch point to where it first touches the ground. We take our data, order it from shortest to longest distances, and then calculate the median and the mean for the data. We are now ready to compute the glide ratios for the shortest distance, the longest distance, the median, and the mean. Using the formula, horizontal distance divided by the change in altitude, we're ready to answer the question, which of the glide ratios that you have computed is the best one to use in describing your plane's glide ratio?